Problems on Newton's laws of motion. A stone of 1 kg is thrown with a velocity of 20 meters per second across the frozen surface of a lake and comes to rest after traveling a distance of 50 meters. What is the force of friction between stone and ice? So this problem talks of there is a pond and there is a stone which has been thrown and which travels at a velocity of 20 meter per second. This is the stone velocity and the stone weight is 1 kg, and this one comes to rest after traveling a distance of 50 meters as per this. So this is where it comes to rest. That means the distance it traveled is 50 meters. So from this diagram and the problem, we have a given data of mass of stone m is equal to 1 kg and the velocity of stone is equal to 20 meter per second, and it stops after a distance of 50 meter. So the distance traveled S is equal to 50 meter. And it comes to a rest. So the velocity after 50 meter is final velocity or velocity after 50 meter. We call it V is equal to 0. So let's say this velocity is V. V is 0. Now with this data, we need to find what is the force of friction between stone and ice. How when the stone is thrown onto the frozen surface of the lake moves on the lake because of the force with which the stone is thrown and the force of friction between the stone and ice. Both the forces act and it comes to a stop because of the force of friction. Now to find out that force, we need to find the acceleration first, since we know force F is mass into acceleration. So in order to find acceleration, we have the data given. So we will find from one of the equations of motion, v square minus u square is equal to 2as, and here v is 0 and u is 20. So 20 square, which is 2 into A unknown and S is 50 meters. Hence A is equal to minus 20 into 20 by 2 into 50. So 2 tens and 10 twos, 10 fives and 5 twos, which becomes minus 4 meter per second square. So the force of friction between stone and ice is mass is 1 kg into A is minus 4. So minus 4 Newton. Two objects, each of mass 1.5 kg, are moving in the same straight line but in opposite directions. The velocity of each object is 2.5 meters per second before the collision during which they stick together. What will be the velocity of the combined object after collision? So from this we understand there are two objects, each of the same mass, traveling in the same straight line but in opposite direction, and the velocity of each object is 2.5 meter per second before collision, and during this collision they stick together. So they travel together. So what is the velocity of the combined object after collision? So let us find out what's happening. Basically, now they collide. A and B, and they collide. Now we want to know what is the velocity with which it travels after the collision. So let's see, from the figure we understand that A and B are traveling. Let's see what is the momentum of each of them. Total momentum before collision and total momentum after collision. Law of conservation of momentum states that total momentum before collision is equal to total momentum after collision. So total momentum before collision, if you see, is for the object A, we'll say mass as ma and velocity is va and vb. So ma into va plus mb into vb is equal to the total mass ma plus mb. Since they are stuck together, the mass becomes ma plus mb. So m becomes 1.5 plus 1.5. So ma plus mb into the velocity. Since they are stuck together and the velocity is the same, which we call it as v. So now this is 1.5 into 2.5. This momentum mb into vb becomes a negative momentum because it is in the opposite direction. Since they are in opposite directions, so total momentum before collision becomes negative. So minus 1.5 into 2.5. Though called total momentum before collision as these two, since they act in opposite directions, so the total momentum here, instead of plus, it becomes minus because it is in opposite directions. Since the objects A and B are moving in opposite directions, this becomes minus. So this is equal to 1.5 plus 1.5 into V. Now this becomes 0. So this is 3 into V. Hence V is 0. So the velocity of the combined object after this is 0 meter per second. So velocity after collision is 0 meter per second, and this is so mainly because A and B are moving in opposite directions. So the total momentum, instead of plus, it becomes minus.